Fire escape engineers inspector summary video here in Rutland, Vermont. We're looking at this fire escape that we're looking to either certify, load test. Part number one is the examination. The examination has determined that the fire escape is not ready to be certified or load tested. One of the first key points is there's no paint on this fire escape, so it hasn't been maintained over time, and nothing but original hardware. I'm trying to see if there's any evidence of maintenance of any great significance, and the only thing I can see is a couple of bolts here and there, but 95+% of this fire escape is original hardware, square head bolts, welds, bends. So I'm going to start talking about what's wrong, what needs to be done here in order to bring this fire escape up to code, and also to prepare it for a load test. Two things. In order to get a guarantee out of this, we need to either spot repair it and load test it, or we can change all the hardware, and that will avoid the load test and you get what's called a certification. So let's start off. First of all, the grating is not secure. The grating is also resting on this angle, and this angle is rotten from the inside out, and it's welded. All welds must be x-rayed or load tested. Otherwise, you put a bolt in it, there is no need for an x-ray or a load test. But the welded connection must be clean of any internal rust. This angle has rust inside. This angle has rust inside, so it needs to be cleaned. Railings, we need more lines in here. If this is a school, we need to have at least no opening greater than 4, or we can mesh up. A lot of times it's easier just to mesh this up, and we avoid the 4-inch rule. We're talking about the supports. We're going to get sealed. Once we seal this up so that water doesn't get in there, it's called ice jacking or rust jacking. We have a combination of those two happening here on this fire escape. Very flimsy connections, so we need to stiffen these things up with angles from the outside, 2x2s. And again with a mesh, so stiffen up the rails. All original hardware. All original hardware that if it's clean and there's no rust inside, then you can load test. Otherwise, you change those 4 bolts. And then you silicone shut the connections, change these 3 bolts, change these connections here, change the outside. As you can see, all original hardware. As soon as you change the original hardware, there's no need for a load test. Okay, here's the connections, all these treads, original hardware. Got to load test them. I'll change every single bolt here, and then you don't need to load test. The rust is starting to grow inside. As you can see, rust is inside. All these bolts are compromised, suspect. Go down even further here. So no paint on this fire escape, and as you can see, right up against this wall. And again, I don't know what happened here, but it looks like some truck damage came to this fire escape. Any welded connection. So here's the only evidence of what's a new hex head, what's an old square head bolt right there. So this is all original hardware. Cannot be load tested at this time. So welded connections, x-ray or load test. Otherwise, you put a clip in here, put a bolt this way and a bolt that way, and you can keep the welds, but you got to seal them up with silicone. Same thing, unverified welded. So x-ray or load test it. Otherwise, put a clip in here, put a bolt there, put a bolt there. We're good. So change out 100% of these bolts to avoid the load test. We've got some damage on the rail down here from truck, so the rails need to be stiffened up. These feet that are buried, once we clean them all up, silicone shut them, we recommend that you tar the feet to the ground, because that's where the snow is going to eat the bottom of these feet. All original hardware on the tread, so 100% of the treads. We got some water damage coming in, so we need to seal this up so water's not getting in here. Through bolt, this is the through bolt, that there's a plate inside. Again, we got to verify, change those bolts and put a bolt on that weld. Change those bolts and put a bolt on that weld. And that's how we're going to guarantee that this thing is not going to fall. Change all these bolts out. Same thing here. See all that rusty stain coming down? That means that water's getting in there. We got to seal that up. And up at the very top, there's an evidence of the through bolts, but we need to verify those on the inside in order to avoid having to load test this. See the angle clip up there? That angle clip is rotten, and so is that angle clip. So we need to cut the welds, break it, clean it, put it back with bolts. You can't weld. Anybody touching this fire escape is older than 78, so it's presumed to have a lead-based paint. So when you scrape this, you have to have a renovator's license. You have to be licensed with the EPA to touch a fire escape that has lead. No welding on this fire escape because it does have lead, so everything is a bolted connection anyway to start with. So what you're going to be doing on this is re-bolt into this fire escape here. Put the rails, you're going to do mesh on the rails to basically meet the code. And whether or not they want to already augment these rails up to 42 instead of the 36, we can do that at this time. Going down the stairs, it's 34 to no more than 38 on the nose. And some of these fire escapes have some bent pieces which we need to deal with. So when you're refurbishing these treads, you know, straighten out some of the noses so that they're all even. And it's a pre-existing structure, so this thing can be repaired. And without a problem, this can be put back into service with minor modifications. Any questions, fire escape engineers? This is Inspector Meneses here, 866-649-0333. 866-649-0333.